Welcome to number 7 in the series of using the equation editing software MathCast. Now we're into trigonometry. So let's have a look how powerful this tool is. So first of all, we're going to pull up a right angled triangle. So we have an angle theta with the horizontal. The side next to it is the adjacent. The side opposite is spookily the opposite. And the one on the longest edge is called the hypotenuse. Here we have HYP for hypotenuse, op for opposite, and adj for adjacent. So let's pull up MathCast. We'll go to the edit screen and we're now going to enter. And we're going to go SOHCAHTOA. SOHCAHTOA. Now that is the abbreviation to remember how the sine, cosine, tangent goes. But it's italicized, so we're going to put it into speech, quotation marks, therefore we get it as a nice italicized version, and we're going to paste it into the document and move it around. So we have SOHCAHTOA, SOHKCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's start typing it out. So we have sine equals opposite. If you do double P, you don't pause it, then you end up getting a pi. Opposite divided by hypotenuse. We'll have a couple of spaces, and we just hit the square a couple of times. Then we have cos equals adjacent over hypotenuse, and a couple more spaces, and then tan equals opposite, op, space, op, divided by adj. How's that look? Horrendous. So what we need to do is go in there and make sure these are all non-italicized, and change the spacing here. Adjacent over hypotenuse. Take the space away bit by bit. It's always good to do it bit by bit so you don't become easily confused with not having enough of the having a syntax error. That's not bad. The only thing is the spacing's a bit big, so we can always do quotation marks for the spacing. Just a trick I learned working through. Quotation mark spacing, and it just means the spacing is a little bit less. We'll copy that, put it into there. So we now have, drop the sign down there, drop this round. So we now have sine S is OH, opposite upon hypotenuse, cosine is adjacent AH, and tangent is opposite over adjacent. So these are the words all in non-italicized format. So let's have a 45-degree triangle. So sine of pi by 4, sine is the opposite over the hypotenuse, so sine is the opposite over the hypotenuse, 1 over root 2, which you can actually make it a bit tidier by saying it is root 2 divided by 2. And then just to back it up, because it makes it look a little bit better, having brackets here, sine pi by 4 is that. So sine is opposite of hypotenuse, cosine is now adjacent of hypotenuse, and to make it a lot easier, if we just double click on that, Control C down, add another line, paste it in. Cosine of pi by 4 is exactly the same. Cosine is adjacent over hypotenuse is now the tangent. Put that one there. Now the tangent is opposite over adjacent. So again we'll do the same copy trick. Control C, Control V. Tan of that is the opposite of adjacent, which is 1 over 1, which equals 1. a different triangle. We have a 1, 2, root 3, a pi by 6, a pi by 3. That's basically, well, I must make sure I do that. So to change from 360 degrees, I'm going to add 360 to 0 equals 2 pi. So 360 degrees equals 2 pi. Control C, add Control V, so 1 degree is 2 pi divided by 360, which is pi divided by 180. Oh, and I've just seen that we need to have brackets there. That's better. 1 degree is that. Just a conversion rate there. Now we've got pi by 3 and pi by 6. Pi by 3 is 60 degrees, pi by 6 is 30 degrees. If you can redraw this triangle by having side 2 here, side 2 on the bottom and side 2 the other way, and you have a 60, 60, 60 equilateral triangle. Angles add up to 180. Same with this one, you can reflect it and have a base of units 2, height of unit 1 and root 2 there again. So you have pi by 4 and 90 degrees on the top and pi by 4. So 45 degrees is 90 plus 90 is 180. Same here. So we can have going to control that one and then sine of pi by 6 is opposite of hypotenuse 1 over 2, which equals cos of pi by 3. Is that correct? Well, if we go there, sine of pi by 6 is opposite of hypotenuse 1 over 2, and the cosine of pi by 3 is adjacent over hypotenuse 1 over 2. So then logically you should then also have sine of pi by 3 equals cos of pi by 6. Sine of pi by 3 is opposite over hypotenuse, root 3 over 2. And is that okay? Sine is opposite, root 3 over 2. Cosine of pi by 6 is adjacent over hypotenuse, root 3 over 2. Let's go for tan. So tan of pi by 6. Let's go for tan of pi by 3 initially. Tan of pi by 3 is opposite adjacent, root 3 over 1. Which is just root 3. And we'll have tan of pi by 6 is opposite over adjacent 1 over root 3. And tidying it up, you can have it root 3 over 3. There we go. So that's a complete triangle by doing it from first principles, remembering that you have SOHCAHTOA, sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite of adjacent, and by having a 1, 1, root 2, 45 degree angle triangle, that's 45 degrees. Sine of pi by 4 is root 2 over 2. Cos of pi by 4 is exactly the same, we expect that to do, and tan of 45 degrees is a 45 degree angle, is 1 and 1. Absolutely fine, logical. 360 degrees equals 2 pi. 1 degree is 2 pi divided by 60, which is what pi divided by 180. And then we have a 60-60 equilateral triangle, 60 degrees, if you reflect it. Then you have the base of 2 units, there's 2 sides of 2 units, and this one's root 3. And then you can derive sine of pi by 6 is a half, which is cos of pi by 3. Sine of pi by 3 is root 3 over 2, which is a cos of pi by 6. Tan of pi by 3 is root 3 over 1, and tan of pi by 6 is 1 over root 3. And here's a table that you tend to find in these textbooks that shows this is how you convert them. So handy though it is, it's actually really good to start from first principles, because it makes it easier to derive and understand where they come from, as opposed to trying to recall and get the wrong number. Well, that's all very well, but what about the case where you don't have a right angled triangle? So you have a triangle like on the screen here, where you have angles that are not perfect. 90 degrees, not pi by 3, pi by 6, 30 degrees, 60 degrees, or 45 degrees. So you have 3 sides that are different lengths and different angles. So you see with the capital letter A, that is the angle A, and the side opposite that is little a. And similarly with angle B, big B, capital B, the line opposite, the side opposite is lowercase b. And for the angle C, the side opposite that is lowercase c. So how do you work this out? Well, it depends on what you're given. Let's bring back up the screen here, and I'm going to add this equation: a over sine A equals b over sine B equals c over sine C. So of course that hasn't worked out perfectly, because we need to put in the brackets here. So a over sine A equals b over sine B. Make sure we bracket it on the denominator here, equals c over sim. No, I don't think so. Sine C. Happy day, that's better, isn't it? So that's the sine rule. So when you copy that one, I'm going to put that one back onto the page. So that's brilliant. So you've got a relationship here. You've got 1, 2, 3, 4, 5, 6. You've got 3 lengths and 3 angles. So the usual guide is that you can solve any equation as long as you've got only one variable in that equation. So here I could have the letter A to find out, but I know the angle A, the angle B, and the length B. Or I know the length B, and I need to find the angle B, but I know length C and the angle C. All very well, but what if you don't get all those information? What if you've got something, only one angle, for example, or 2 sides? And this way you get into, this is a sine rule, now we get into the cosine rule. Whoops, just going to add another equation, a squared equals b squared plus c squared minus 2bc cos a. Whoops. So that comes, if you type a letter more than once, it tends to come up with the Greek letter. A squared equals b squared plus c squared minus 2b, that's why, 2bc. So the variables are italicized. So you've got a squared, b squared, c squared, 2bc. The bc's are italicized. Cos a is in the correct term. So I'm going to copy that one in and put that into the equation. So this is a case where you need to find a, but you know the lengths b and c, and you know the angle a. So you'll see that with the sine rule you need at least 2 angles or 2 lengths. Here you just need 2 angles, 2 lengths and an angle. And you can rearrange that one, and this is very handy. So stop retyping it all out again. You can take this line command and then add another line, and then just go, right, we're going to put that one, because it's a minus. If I now float it over to the left across the equal sign, that becomes a positive, and then I'm going to put the plus a squared and control exit across to the right, and that becomes minus. Always show line by line working where you can. So you've got the first rearranging of that one as 2bc cos a equals b squared plus c squared minus a squared, and then divide both sides by 2bc, and then we're going to just copy that one again and then add, and we can have take that off. It's multiplying it, it's now going to divide it. So of course I know what's going to happen with this one. It's going to make it look awful. Oh, look at that, awful. So I need to put some, I'll try brackets first and see if that works, and then try the bracket there. There we go. B squared plus c squared minus a squared over 2bc. Units wise, the top of the equation, they are squared lengths, all three of them, b squared, c squared, a squared, and then the bottom of it is b times c, so that's a squared length as well. A cosine is a value which does not have units, so these units cancel. And that's the physicist in me working. I love to see that. Always check units. So I can put that one there. Just move that one along a little bit. Now underneath, there we go. So you've got all the equations there, and again, as with everything, you then have this method for, does the triangle contain a right angle? Yes. Does it involve only lengths? Yes. And you've got Pythagoras theorem, c squared equals a squared plus b squared, or no. Then you've got the trigonometric ratios, SOHCAHTOA, sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Or if it doesn't have a right angle, do you know a length and the angle opposite, or can you find the angle opposite? Yes. Sine rule, no. Cosine rule. And now we finish here, we need to make sure that we actually save our work, our file here. So I'm going to file, save as, and I can just go example number 2, number 3, trigonometry. Here we're done, save that one. And then if I just file exit. Now we finish off with the conclusion of number 7 in a series of using equation editing software, and with the reference as always. Thank you for watching, take care now, bye bye.